Hi, welcome to our math today. On this video, we are looking at rational functions, and specifically on this one, it says simplify and identify the domain. So to simplify, we are going to have to factor, one of the many beautiful F words of math. So we'll start with the first one. To factor a trinomial, we need to find two numbers that multiply to 30 and add up to 13. So because 30 is positive, the factors need to have the same sign. Because 13 is negative, they both need to have a negative. So negative 1 and negative 30 do not add up to 13. Negative 2 and negative 15, that's 17. Negative 3 and negative 10 is perfect. So we end up with 8 over x minus 3 times x minus 10. With 8 in the numerator, this is not going to be a reducible fraction, but we needed this to figure out the denominator, because the thing about a denominator of a fraction is it cannot equal 0. But based on the zero product rule, when two things multiply to be 0, one of them has to be 0. So it's either x cannot be 3 or x cannot be 10. So if we look at a number line and we include 3 and 10, basically x can be anything on this infinite number line, because we go to negative infinity over here and positive infinity over here. Negative infinity is always on the left. Positive infinity is always on the right, except for these two exclusions. I'm going to write this in set notation. So negative infinity to 3, joined with 3 to 10, joined with 10 to positive infinity. You could write this verbally. You could say all real values of x except 3 and 10. It's a lot of words to have to write down. This is much simpler, much faster. All right. For our next one, if we look at this, it says simplify and, which means I have to factor top and bottom. The numerator is pretty simple. It's a difference of two squares. So x plus 9, x minus 9. Now, even if we can simplify it, the domain is still restricted by whatever was originally in the domain. So if one of the factors in the denominator is an x plus 9 or an x minus 9, that is still a restricted value in the domain. If graphing, here, let's get this done really quickly. This is a negative, this is a positive, so that means, what does that mean? It means the 36 is positive and the 1 is negative, so they add up to a positive and multiply to a negative. That does not add up to 5. Negative 2 and 18 also does not add up to 5. Negative 3 and 12. Negative 4 and 9. There we go. Okay, so we have this over x minus 4 and x plus 9. So this is what this means. This is still restricted out of the domain. So x cannot equal 4, x cannot equal negative 9. If we look at our number line, we have our negative 9 to the left of 4, because negative 9 is closer to negative infinity. So our domain is negative infinity to negative 9, joined with negative 9 to 4, joined with 4 to positive infinity. What this means is if we were to graph this, there would be a hole in the graph at negative 9, what is this, negative 18 over negative 13. So at 18 over 13, there would be a hole at the graph at that point, and there would be something called an asymptote at x equals 4. And an asymptote is a barrier the graph does not cross. So when you can reduce it out, it's a hole in the graph. And when you cannot reduce it out, it's an asymptote. And so that's the difference of what's happening here. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.